Are you struggling to name these type of complex molecules and don't know where to start? In this video, we'll be talking about how to name organic compounds for the IGCSE Chemistry. Before we get to complex molecules, let's start off with some basic molecules. To start naming basic molecules, the first step is the prefix. The prefix depends on the number of carbons present in the molecule. For example, if there is one carbon, the prefix is met. If there are two carbons, the prefix is ed. 3 carbons will be prop, and 4 carbons will be but. For IGCSE chemistry, you will only need to know up to only 4 carbons. After the prefix, the suffix will follow, or the end part. For the suffix, it depends on the type of functional group present in the molecule. For example, if the bonds present are all single bonds, that will be an alkane, so its suffix will be -ane. For molecules that contain at least one C double bond C, the suffix will end in -ane. For alcohols, there will be an OH group and the suffix will be ANOL. For carboxylic acids, the ending will be enoic acid, as in methanoic acid, ethanoic acid. Suppose we have this molecule here. The first step is to count the total number of carbon atoms. Here we have 3 carbon atoms. So what's the prefix for 3 carbon? Yes, it's prop. Next, we will look at the type of bond present between the atoms. Here all the bonds are single bonds, so this is an alkane. An alkane that contains 3 carbons will be called propane. Let's try another one. Here we will do the same. First, let's count the number of carbons here. There are 4 carbons, so the prefix will be but. And then there is the functional group OH, so this is an alcohol. An alcohol with 4 carbon atoms will be called butanol. Moving on to a little bit more complex molecules like this, we will still follow the same steps. First, we count the total number of carbon atoms here. We have 4 carbon atoms here. And what about the functional group? We have an OH group here that is connected to this carbon atom. Since there is an OH functional group, this is an alcohol. And what's an alcohol with 4 carbon atoms? This is also a butanol, but this one has a different structure to the previous butanol. So we call these isomers. This one here is an isomer of the previous butanol. Isomers are defined as compounds that have the same molecular formula but different structural formula. To name these type of isomers and more complex molecules, the first step we have to do is to identify the longest unbranched chain of carbons and give its root name. As you can see, it says unbranched here. So in other words, it just means that we have to select the longest continuous or straight chain of carbons. Let's look at an example. If we have a molecule like this, the first step we will identify the longest continuous chain. Here we have these 3 carbon atoms in a straight chain like this. In the next step, we will look at the type of bonds present. Here all the bonds are single bonds, so this is an alkane. An alkane that has 3 carbon atoms will be called propane. So propane will be the name of the parent chain in this molecule. The next step is to number the chain so that the important things get the lowest possible number. What are the important things we are talking about? For alkanes, These will be the side branches, in other words, substituents, like the methyl group or halogens. For alkenes and alcohols, these will be the double bond or the OH group. In other words, the functional groups have to get the lowest possible number when numbering the straight carbon chain. So let's try numbering the carbon chain like this from left to right. Here we have this methyl group. Let's see which carbon it's connected to. This methyl group is connected to carbon number 2, as we can see here. So is this the lowest possible number we can get? Yes, because this carbon is in the middle. So if we number the chain from left to right, this will be carbon number 2. And also if we were to number the chain from right to left, this carbon will also be number 2. The last step is to put all these pieces together in this order. First comes the number. This number will determine the carbon number that the substituent is connected to. And this substituent means the side branch, like the methyl group. And lastly, the main chain. This will be the longest straight chain or the parent chain. Also, be careful to put a dash between the number and the substituent. But there will be no dash or space between the substituent and the main chain. So let's try this together. First, we will write the name of the main chain. And since it has 3 carbon atoms for the longest continuous chain, this will be propane. Next comes the substituent, and here we have a methyl group as the substituent, so we will write methyl. And lastly, we will write the carbon number for which the methyl group is connected to, which will be carbon number 2. The final answer we get is 2-methylpropane, with a dash between the number and the substituent, and no space between these. Let's try applying the same steps to different functional groups, starting off with alkenes, which will have C double bond C as the functional group. The suffix will be "ene" for these alkenes. Let's take a look. First, we will identify the longest continuous chain, and here we have these 4 carbon atoms connected in a straight chain. And since this is an alkane, we can see a double bond between the first 2 carbon atoms. Since this is an alkene with 4 carbon atoms in total, this will be called butene. The next step is to number the carbon atoms in the longest chain. But remember that for alkanes, the double bond has to get the lowest number. Let's try numbering the chain from left to right like this. As you can see, the double bond is here between the first carbon atom and the second carbon atom. For the double bond to get the lowest number, we will have to select carbon number 1. So the double bond is on carbon 1. But if we were to number the chain from right to left, like this, the double bond is no longer on the lowest possible number. Alright, let's put the pieces together. We have the parent chain, butene, and we will write this in this way. The prefix and the suffix, and we leave a space in the middle. For that space, we will write the carbon number on which the double bond is connected. And we want to get the lowest possible, so it will be carbon number 1. What about this one? As usual, we will look for the longest continuous chain of carbons. Here, we have these 4 carbon atoms connected in a straight chain. And we can see a double bond in the middle, so we can tell this is an alkene. An alkene which has 4 carbon atoms in total will be called butene. So this is also a butene, but this has a different structure from the previous one. That's why this given molecule here will be an isomer of the previous one. The next step will be to number the carbon atoms so that the double bond gets the lowest possible number. Here, we will number from left to right, like this. The double bond is on carbon number 2. And if we number the chain from right to left, the double bond is still on carbon number 2. Putting all the parts together, we will have the parent chain first, butene, and leave a space here. For the space, we will write the carbon number that the double bond is attached. And that will be number 2, since the double bond is on carbon number 2 when numbered left to right or right to left. Moving on to alcohols with the OH group. Their suffix will be OL. Let's take a look at this. The first step is always to identify the longest continuous chain. So here we have these 3 carbon atoms connected in a straight chain. And then we have the OH functional group here. So an alcohol which has 3 carbon atoms will be called propanol. The next step is to number the carbon atoms so that the functional group gets the lowest number. If we number the carbon atoms from left to right like this, the OH group is on the 3rd carbon. But this is not the lowest possible number we can get. But what about numbering the carbon atoms from right to left? Now the OH group is on the 1st carbon, so this is the lowest possible number. Let's put these all together. First, we have propanol, which is the name of the parent chain. So we write this in this form, the prefix and the suffix, and a space in between here, just like we did for alkenes. For the space, we will write the carbon number that the OH group is attached to. And it will be 1, since the OH group is attached to carbon number 1. What about this one? First, we see that there are 3 carbon atoms in a straight chain, and there is an OH group here. So this will also be a propanol molecule, but now this is a different structure of propanol since the OH group is connected to the middle carbon atom. Alright, we will try numbering the carbon atoms so that the OH group gets the lowest number. If we number it like this, the OH group is connected to carbon number 2. This is the lowest number we can get since this carbon is in the middle. Moving on to haloalkanes. These are formed when alkanes undergo substitution reactions with halogens. And the prefixes we will use will include chloro, bromo, depending on the type of atom substituted. Here we have this molecule. First, we will identify the longest continuous chain. We have this chain of 3 carbon atoms, and all the bonds here are single bonds, so we will call this propane. Propane will be the parent chain. Next, we will identify if there's any substituents here, and yes, there is. Here is a chlorine atom. This will be the substituent here. The next step will be to number the carbon atoms so that the substituent gets the lowest number. We will number it from left to right. So here, the chlorine atom will be attached to carbon number 1, which is the lowest possible number we can get. We will put these all together in this method. The number comes first, and the substituent, and lastly, the main chain. First, we've identified that the main chain is propane, since there are 3 carbon atoms here, and all the bonds are single bonds. For the substituent, we will use the prefix here, since the substituent is a chlorine atom. So it will be chloro. And lastly, for the number, we will write the carbon number on which the chlorine atom is attached to, which will be number 1. The final answer we get will be 1-chloropropane, with no space between the prefix and the main chain. Let's try a harder one for the final example. Here we have this molecule, and as usual, the first step is to find the longest continuous chain of carbons. Here we have these 4 carbon atoms connected in a straight chain, and there's this double bond here. So this is an alkene that has 4 carbon atoms. What do we call this? Butene. So butene is the name of the parent chain for this molecule. For the next step, we will look for any substituents or side branches. Here we have this bromine atom connected to this carbon atom. In this case, we have both the double bond and the substituent. So what do we prioritize? Since the longest chain is a butene, we will prioritize the double bond when numbering the carbon chain. So let's try numbering it like this, from right to left. Here, the double bond will be on carbon number 1. Okay, so we have the name of the main straight chain, but1ene, since the double bond is on carbon number 1. Next, we will look for the carbon number that this bromine substituent is connected to. Since we number the chain from right to left, like this, the bromine atom is connected to carbon number 3 here. And since the substituent is a bromine atom, we will use the prefix bromo. Okay, so to put these together, we have the parent chain first, which is but1ene, and the next one will be the substituent name, which is the prefix bromo. And lastly, it's the number where the substituent is connected to. So it's carbon number 3 here that this bromine atom is attached to. The final answer we get is 3-bromo-but1ene. Okay, finally getting back to the example I introduced you at the start of the video. We will follow the usual steps. So first, we will find the longest straight chain of carbons. We have these 3 carbon atoms, but it's the same if you count it from top to bottom like this. So the longest straight chain will still be 3 carbons. And all the bonds here are single bonds, so this is an alkene with a straight chain that contains 3 carbon atoms. So the name of the parent chain will be propane, since it has 3 carbons and all the bonds are single bonds. Next, we will look for any substituents or side branches. And here we have 2 methyl groups attached to this carbon atom. And then we will number the longest straight chain of carbons so that these methyl groups get the lowest number possible. We will number it from left to right like this, and the methyl groups are attached on carbon number 2. And this will be the same if we number the chain from right to left, since this carbon is in the middle. Because these methyl groups are 2 identical substituents, we will use the prefix di in front of the word methyl. And because both of these methyl groups are connected to carbon number 2, for the numbers, we will write 2, 2. Finally, we will put all the parts together. First, we have the name of the parent chain, which is propane. And next will be the name of the substituents or the side branches. Here we have 2 identical methyl groups connected onto the same carbon atom. So we use the prefix di in front of methyl. So it becomes dimethyl. And lastly, the carbon number on which the methyl groups are attached. And it will be 2, 2, since both of these methyl groups are connected to carbon number 2 here. The final answer will be 2,2-dimethylpropane. But you don't really have to know these type of complex molecules, since for IGCSE Chemistry, they can only ask you up to 4 carbon atoms. Alright, this is the end of the video. Thank you so much for listening and see you in the next video.